Welcome to the 116th episode of the Flipped Learning Network podcast. I'm your host, Troy Cogrum, along with my co-host, Joan Brown. And today we're going to be talking about maker spaces and learning through making and education. And we have Dr. Kylie Peppler. Kylie, will you tell us about what you do and your role in education?
Sure. So I'm a learning scientist here at Indiana University. I'm in the School of Education. And so what I do is I study learning, and actually I design new learning experiences for youth. And so I've been looking at this intersection of kind of the arts and new technologies and how they come together and how they inform one another.
So tell us, we've done a podcast, we've actually done two podcasts on the maker spaces, but we've done it from the K-12 educator side, not necessarily from the higher ed side and what maybe the research says about it and things like that. Can you give us a little bit of sort of the history of the maker movement as you know it?
Sure. Really the beginning of the maker movement is probably around, the beginning of the 1900s or so, with John Dewey's work and really kind of thinking about putting making at the center of education and really blurring the lines between school and life, and thinking about schooling as really the preparation for life. And so that's why, this current modern day, kind of swing, I think it comes back up. Really, the height of it's been in the last 5 years or so. And so this all started, the father of the maker movement, the modern day maker movement's really Dale Doherty. And he was really had his eye on, what it meant to be a maker, and started putting together this whole movement today. And so you start to see kind of the 3D printing, all of these things that kind of arc back to our more historical ways of making, the woodworking, the arts and crafts, the sewing and the crochet, but with a new technology spin on all of that. And so this is sort of popularized through sort of robotics or other kinds of integrations of the technology and these like traditional shop and kind of home ec kinds of forms. And so I think it's captivated everybody's interest in part because it's a lot of the old and a lot of the new kind of mixed together.
Yeah, I kind of call it, when people ask me, I say it's kind of a modern day shop class, and kind of, it's kids tinker, and we just give them the tools to discover, and that's
right.
That's kind of
I would call it a modern day home ec class.
Okay, I'll revise that then. That's what I'll start calling it, because it makes a lot of sense when you've been in one, but people who haven't kind of seen that environment, they're like, I can't quite wrap my head around what it is, and it's just like you let kids explore. It's an inquiry-based system where you just give them the tools and say, go for it.
Right. Yeah, I think it's so important too. It's we in a good effort, we've moved away from trying to have these two tracks in schools. But in the process, we've removed shop class, we've removed home ec, we've removed a lot of the things that have the hands-on learning in an effort to prepare everybody for college and to have more room for sort of remedial teaching. But I think in the process, we've lost so much.
So, one of the things that I've been curious about is, are there any people opposed to having maker in the schools? Is there anyone out there trying to say, well, wait a minute, aren't we supposed to stay with more philosophical kinds of learning? Or no?
Right, absolutely.
I haven't heard anyone opposed to it, so I would think the only barrier is really just financial.
Right. It is. It's amazing, right? I think it's a particular moment of what's happening, today, that it really, I talk about it in terms of it's really being pulled into schools. I never have anybody saying, no, I don't want this here. I did actually just read an article about a particular naysayer, I think on the Atlantic, and I can send you the link to that later. But in general, most teachers are saying yes to this. It only takes one small hands-on experience, and all of a sudden sudden they can start to see the ties to all of their academic areas, to information writing and the language arts curriculum, to math, to science, to engineering, the next generation science standards. It's just is a whole different way of thinking about all those traditional content areas. And then, once teachers try it out in their classroom, they're hooked, right? It's the kids that they couldn't reach previously are now engaged. The understanding is so on topic and on focus. It really doesn't take much to get it in.
So you're part of the creativity labs at Indiana, and so you guys do a lot of research. Is that on this area?
We sure do. We've been I've been researching this kind of stuff. Again, it's hard to even remember, for the last 10 years or so. It started off looking at e-textiles or electronic textiles, and we can talk a little bit more about those if you like. And then sort of thinking about what that meant, this little sub-community of e-textile designers and sort of the larger maker movement.
So yeah, go ahead, and if you want to talk about e-textiles, it goes a lot. It goes along with this creating or making for learning. So tell us what e-textiles are and kind of what you found with those.
Sure. Well, it's been really productive. So e-textiles has been sort of this merger of the high and the low tech together. And so it's these little sewable computers that can kind of be sewn into clothing, and it's sewn in with a special kind of thread that looks and feels a lot like thread, but it's actually more like a wire. It's little, kind of metallic fibers that are sewn woven together, and so it's it replaces all of the soldering and the kind of the insulated wiring in a circuit with this conductive thread. And then you can sew in any type of traditional electronics. So you can put in LEDs or other kinds of outputs. Sound or speakers can then be sewn into clothing. You can put little sensors. So if you push a button, something will happen to your shirt and so forth. It's been really popularized. Old Navy was selling hoodies with earphones in them, for example. This merger of the cloth or the textile with the technology. The kids are wearing stuff in their shoes. Increasingly, you're seeing this in their shirts. And so, what does it mean for someone to be able to build and design these materials and actually design new kinds of things? And so, we've been working with Leah Buckley, the designer of the LilyPad Arduino, an open toolkit that you can actually order in the mail and start making your own e-textile. And we've been just really studying these over time. What does this mean for making? What does this mean for classroom learning? How does this tie to the kinds of things we traditionally want to teach in science or in language arts or in math? And does this actually improve our learning outcomes over time?
And what is it that you've been finding?
Well, it's been really interesting. So we've been looking at circuitry learning, and so you probably remember back to around 4th grade or so, and maybe you're actually teaching this lesson in your classroom. But a simple circuit has a battery in it, an LED or a light bulb, and then some wiring and maybe a switch in there. And so that's typically taught in 4th grade. And then electronics get increasingly more complex, and you might have this again in physics in high school. But what we know is by the time undergraduate majors in physics or engineering or computer science get to college, they never really understood this stuff. And it turns out that our tools and materials actually don't teach it very well. It gives you an experience where the light bulb goes on, but conceptually you didn't have to engage in the big ideas of circuitry. And so the problem there is that that people forget it. So you're probably listening thinking, oh yeah, I remember having something on circuitry, but I don't remember it. I don't remember the details. And so what we're finding with e-textiles is that they're sticky. They're really conceptually well aligned with the concepts that we want to teach. So if you're familiar with circuitry, you want to be teaching current flow, you want to be teaching polarity, you want to be teaching connectivity, and the kinds of connections in there. And so as you think about it, you have to sew something. So imagine sewing a button on. You have to make a really tight connection. in a typical kind of circuit is that you just open a clip or you snap it on, and so you don't have to think about the quality of that connection. So you can kind of start to see how these materials might conceptually engage us better in the content. And so we've been looking at transfer tasks, we've been looking at how long the kids retain this information, and it's really quite amazing. Compared to the school kits, there's just no comparison. Actually, we tested 5 different popular kits in the maker movement, and the worst one came out to be the typical school kit, and the top level one ended up being the e-textiles. So we're finding that they're transforming the way we conceptually engage in the content. But we're also finding that this kind of, they're not only good for learning, but they're also good for inviting girls into STEM careers. And
that's what I was hoping you would start to say.
Yes, exactly, right? And so this merger of this high and low tech is actually important. It's a merger of 2 cultures, right? It's a merger of traditional women's crafts and traditional kind of shop culture and electronics culture. And so because of that, it kind of sits at this really nice center. You might think, oh, well, boys would be disinterested. And it's not true at all. What happens is when we bring in the craft, it allows us to kind of create more expressive and artistic kinds of circuits that's more interesting to everybody and more conceptually engaging. You know, in most kids, if they're learning something, they're really tuned in, right? And so you can imagine if you're learning more about how circuits actually operate, you're even more tuned in. And so, and then that combined with, being able to wear it, like teens and tweens, fashion is all of the rage. So just the applications. And then you get to take them home. Think about most science toolkits as you take it apart and you leave it in the science room, reuse them later. But think about something that could actually be sewn into a t-shirt. It gets to leave with you. So you're telling your friends, you're telling your parents about how circuits operate. You're describing how you did this and the process behind it. So you can see how robust the whole ecology around learning is and why we start to see these really great gains here.
Well, you see the connection, too, with wearable tech. And that can, increase the number of concepts exponentially. I mean, you can go into the medical fields, into the health, in fitness and so forth. I can imagine, a shirt where, if my back aches, I can turn on the heat, just on the shirt, and that kind of thing, as simple as that. But some of the stuff that I'm seeing, at least with wearable, it's fashion. That is where this is going. I mean, with the LED lights, it's insane. And it's coming out with the designers even.
Oh, I know. It's everything from the Super Bowl halftime show to like Lady Gaga's costumes. They're all, it's very, very high-end kind of stuff. And it's really technically complex. People always kind of say, well, is it as complex as, say, traditional robotics? And I say, actually, it's more complex. You've got to simplify it. You've got circuits that are uninsulated, so you have to think about whether they're going to short or not. And so, even when I get like PhDs in physics or presidents of the undergraduate robotics club, they still love e-textiles because it's conceptual content that was vague to them before they came to it, and they get hooked. People that I've had in my research group, years ago, are still running small companies. They're still doing e-textiles as part of their hobbies on the weekends, right? And these are proficient men that have their PhDs, have their their undergraduate majors in these areas, and still are getting hooked on this kind of stuff. But there's not just fashion applications. I think for your listeners, it's important to know that it's not just all fanciful kind of work. Is that this is revolutionizing kind of healthcare industries like you mentioned, but also a lot of military applications too. So you can imagine what this means to be able to monitor troops in the fields and the conductivity of their skin, which tells you whether they're dehydrated or not.
And I've seen it similar in the sports, especially professional sports. You'll see on the sidelines they have, computers that they're monitoring things implanted in the players' jerseys, so they know who's more tired and things like that. So.
Right. Well, and even other sports applications where they can make custom kinds of outfits, to like look at and diagnose repetitive stress injuries before they actually happen. right? And so then they can visualize this kind of stuff. And so you can, now that these commercial tools are available, Microsoft is inventing things, the sports industry is doing it, but also, everyday hobbyists are doing it. And the other thing that's really cool is we looked at, my colleague Leah Buckley had looked at, who's making what. And so the LilyPad Arduino is kind of the most popular commercial tool out there right now to build e-textiles. And so they're used in schools, but they're also used by Microsoft, which is a really fun commonality. And then there's a little kind of brother robotics tool called the Arduino, which is kind of the one that is part of this family of the LilyPad Arduino. And there's actually quite a few different kinds of Arduinos that support different kinds of robotics. And so when we look at kind of who's designing with the Arduino, she found that only 1% of the designers are female. And the rest are men, or they can't track down the gender of the designer. And then by contrast, on the LilyPad Arduino, 65% of the designers are women, and so you can start to see the stark contrast there, and why this is starting to, because of the different kinds of things that you can make, the different kinds of practices like sewing that are privileged, why it starts to reshape, the whole STEM pipeline we've talked about for years.
Where's the influence, I guess? I mean, as far as like what students are entering this area of study in college? What backgrounds are they coming from? The people doing this research and things like that.
Right. So a lot of people are coming at it from very different directions, right? So when I look at who's studying the maker movement, who's studying e-textiles, some of them are kind of coming at it, from education and looking at the possibilities here, and learning sciences as part of that. Other folks are coming at it from engineering perspectives or from computer science, and are really interested in building up new courses, trying to broaden pipelines in college to bring in more girls into these majors that have been historically underrepresented. There's a brand new Intel report that actually says we're worse off than we were in the 1980s in terms of bringing girls into STEM fields. And so you can see this is a critical area, whether you're a practitioner at the higher education, or whether you're a researcher kind of studying this. It opens up a lot of new possibilities. So that's really exciting. The students that then come to sort of work with us, they come from a variety of backgrounds as well. Some of them are designers, some of them, like I said, the president of the robotics club, the engineer, the physicist. Lots and lots of different interests in these kinds of new materials. And then what people are making with it is just, there's always something that just blows my mind.
I guess we should mention, for the listeners who may not know what an Arduino is, it's the best way to explain it is it's a computer chip that you can, put inputs and outputs from, and in essence make a computer out of it.
Right. I think that's a great explanation, and it's also one of those tools that's sort of ubiquitous in the maker movement. So if you subscribe to Make Magazine, for example, a lot of what you're going to see in there is all built on Arduino, and so it's been a really great tool for hobbyists to be able to start to build and invent all sorts of new kinds of robotics. Everything from like a lock on your door that can respond to your knock, to a specialized robot, or almost anything else that you can imagine.
I just got the Sylvia's super, I'm forgetting it, a super project book or whatever it is, and almost every single one of them is Arduino. I mean, it's like page 1, go buy an Arduino, and then you can do all this.
Yeah, she's amazing. That's great. Yeah.
I was listening to some music that had been created through an Arduino, and I was very impressed. It was actually music and video combined. It was phenomenal the way they had the inputs for you to kind of create it, but it built it on what you were inputting. I was amazed.
Wow, yeah. I mean, electronic music. We've done some things with the LilyPad Arduino where we, created a costume for a dancer, and it allows the dancer then to control the music.
Ooh, wow.
That's neat.
So, are you familiar with the 20 time or the Genius Hour concept that's growing in K-12 environments?
Right, yeah, yeah, I think it's fantastic.
Is that, do you guys do any research as far as that, or is that just something that you're familiar with?
Well, we've been using that time to kind of look at what basically we could take from the out-of-school learning environment into the in-school learning environment. And so a lot of our studies will actually take place in this like little, time that allows for free exploration and kind of open-ended. It doesn't have to be as tightly structured by the curriculum, and so or the standards. And so we use that time to collect our data. We actually haven't looked at the impact of incorporating that time into schools. In part, a lot of times I see schools, especially a lot of schools trying this out, are really kind of experimental and trying things, and so their ability to kind of adhere to this initial plan has been challenging and difficult in practice.
Hmm.
So when you look at secondary ed, a high school, for example, what do you think is going to need to change and alter in order to sustain these types of, I guess, experimentations done by students?
Right, right. I mean, it just is rippling, and so I'm really excited because we're starting to think about actually this could really be a way that we could reinvent schools, not just K-12, not just having a little makerspace at the side, but we can start to re-envision how schools of education could even operate. And so we've started, this year at the IU School of Education at Indiana University, we're opening up a new makerspace in the School of Education. And so what this is meant to do is to be a demo space, so people don't start to use it like a typical teaching classroom, but they can actually see how do you store materials, how do you think about this kind of work as early as their pre-service education, getting them to kind of experience the model both in their own coursework, but also watching kids coming into the space and actually doing this kind of work. And so what we're really excited about is this could actually pose a shift in the ways that we think about the teacher, about schools, and about classrooms. Right now, we're kind of at a moment where teachers have been deprofessionalized. We stopped seeing the expertise of the profession and the higher education. We get a lot of pushback where we're trying to, put more subject area expertise and less education classes, less classes about learning, less classes about development, less things about classroom management. All of this is being off-tasked to the idea that, if you just knew more about your subject area, you could be a better teacher. And of course, we know in the profession that that's just not true. What we can do, I think, if we start to think about the maker movement and what this means, is that we can start to think about teachers as these expert designers of classroom learning experiences. That everything that we do, from arranging the desks to how we write on the board, or how we relate to children, is actually transforming that learning experience. And so all of these decisions, all these design decisions that teachers have to make on an everyday basis, and as they do that, they start to really design these learning outcomes and to support them. They're not consumers of curriculum. They're not there in the classroom in the way that the popular press likes to portray this, is that they're actually makers of these environments. And so as we start to take on that identity, it gives us more agency. Is like, actually, we are constantly designing, we're constantly making impactful changes to our curriculum, adapting it to the needs of this learner or that learner, kind of thinking on the spot. And so this is all of the kinds of things that we know to be true in both engineering and design thinking. And so by highlighting that, I think we start to really come back to what it means to teach and what gets us passionate about teaching. And so in the School of Ed, here at IU, we've been thinking about that space, but also that new identity. Is that let's not look backwards, let's look forward to kind of thinking about what it could mean to integrate new technologies. How can we support making across the curriculum, support open-ended maker spaces in schools? And so this means new classes, new majors, new learning experiences. Even in higher education, we need to think differently. We need to turn away from those lecture kind of styles of things to think about actually doing as a way of experiencing and learning, but also then tightly coupling that with particular kinds of learning outcomes that we want to cultivate, thinking about deepening learning through that making practice.
Could you see?
Go ahead, Troy.
Could you see in the near future maybe entire schools dedicated to being a makerspace?
Oh, definitely. That's actually already happening. There's several really exciting schools that I can point you towards that are already demo spaces that are just thinking about making. And again, I think it gets us to think about more efficient ways of learning. It's like that example I mentioned before, is that we have to keep teaching a circuit so many times because we didn't have the right tools and materials. We didn't think very thoughtfully about them. They're not well designed. They're not conceptually engaging us in the content. And so as makers, we could actually create the new tools and materials that would actually engage us more conceptually in that learning and deepen those learning outcomes. So as we start to think about it, it gets us to think about learning and teaching in such different and radical ways. I think it's also it's like an epidemic, right? It's not just schools of education that want to transform. It's every department here on campus in higher education wants to think differently. From chemistry, thinking about the kinds of new questions, research questions that they could ask and answer through 3D printers of different chemical models that they could actually then probe them in different ways and answer questions that would have only been theoretical prior to being able to build out some of these models. Fine arts, thinking about how that could revolutionize their practice. Similar to, I just gave you the example of dance and of music. What does this mean for electronic music and schools of music to think about this kind of integration or to make your own instruments? And then everything, School of Informatics and Computer Science, of course, those schools are already on board. And so you could kind of see how every school could really start to rethink, even very traditional fields like architecture. All of a sudden you can print out the buildings and see them in the space, using a 3D printer technology. Same in biology, the really rare artifacts and, kind of like skeletons could be scanned and then printed so you could pass them around your class, right? So each and every one of our disciplines can really radically change thinking about bringing these technologies into it. At all levels, we're fighting for what does it mean to be there residentially when the cost could be so much cheaper to Skype in from home, to do something from a distance, right? Even a lot of high school students are now getting their degrees online. A lot of homeschooling parents are now using online portals, right? And so we really need to think about space and what it means to be present, both for the community development, but also for the hands-on kind of learning. There's a lot of things that can't be learned in 2 dimensions or on screen.
Do you find that the grants are mostly from the businesses that are looking for the next generation of inventors? Is that where we're finding the funding?
I think funders are slowly getting on board, right? So you've seen some leaders like Cognizant, you've seen some leaders like Intel already kind of behind this because they can see what this actually means, both for entrepreneurship, right? People are inventing things that are radically transforming stuff. I just got back from a tour for Russia, and we're really, everybody abroad is really interested in importing American goods, all of the kind of maker culture, the tools and materials, just the way we think about it, the 3D printers, the fab labs, right? A lot of them are American goods that are being exported, and so this does mean a lot for both our economy, for innovation and entrepreneurship.
Well, could you let my listeners know where they could find out more about you and the work you're doing?
Sure, absolutely. So I can be contacted by email at kpeppler@indiana.edu. You can also check out my website at kpeppler.com or thecreativitylabs.com if you want to learn more about the research projects that we have underway. And I'm also like on Twitter channels at Dr. Peppler. That's like at Dr. Pepper, but with the L in there. I'm on Facebook and LinkedIn and other places too.
Well, it was really great to talk with you. I'm going to check out your creative labs. I'd like to see a little bit more about the research too.
Yeah.
Great, excellent. Love that.
And you're certainly passionate about what you do, so that's always good to see people who are passionate about these topics. So.
Yes, absolutely. Yeah, it's an exciting area to be in, and right now, like I said, is the right time to be doing all of this work.
Well, thank you for your time, and I'm sure my listeners will really appreciate hearing a lot of what you had to say. And we always like to try to get back to the research too, because there's a lot of movements that get going that lack research, and so it's good to see that you guys are doing research in these areas. So.
Yeah, excellent, excellent. Yeah, thank you.
All right.
Thank you.